All right, let's check the answer to this problem. A sample of gas occupies 120 milliliters at 25 degrees Celsius. Again, we're at the 25 degrees Celsius and 120 milliliters. What is its temperature if its volume is decreased to 32 milliliters? So I already see that my volume was decreased. It told me that. If my volume decreases, volume and temperature are directly proportional. V over T, V over T. V1 over T1, V2 over T2. Whatever I do to my volume, I do to my temperature. Temperature must also decrease. So this question has to do with volume and temperature. Let's plug and chug. I like to show all my work. V1, again, is 120 milliliters. T1, I wrote it as 25 degrees Celsius, but remember, we need to use Kelvin. If I add 273, I get 298 Kelvin. V2 is 32 milliliters. Oh, I got that now. T2, I don't know. Looking for it. So now, if I plug and chug into this equation, I get V1 over T1 equals V2 over T2. I like to show my work because I know which equation I'm using. 120 milliliters over 298 Kelvin equals 32 milliliters over T2. I already did this math up here. 120 divided by 298 is 0.403. Equals 32 over T2. Now, how do I solve this with T2 in the bottom? We did this in class. If I want to try and get T2 by itself, I have to switch places with T2 and 0.403. The way that I could do that is by multiplying both sides by T2. So times T2 times T2, and I'll be left with 0.403 times T2 equals 32. And then we should know how to do that. If I had the problem that said 0.403 x equals 32, how would you solve for x? Well, of course, you would divide both sides by 0.403. So I'm going to divide both sides by 0.403, running out of space here. And that's going to be equal to my temperature in Kelvin. So if I plug it into the calculator, 32 divided by 0.403, I get 79.4 Kelvin. Now, if I wanted this in degrees Celsius is going to be Kelvin minus 273. So just in case I had asked that, I have it in Kelvin, it's 79.4. That's very small. If I want it in degrees Celsius, I would take 79.4 and minus 273. I get a very negative temperature, negative 193.6 degrees Celsius. If I ask that. And that is how you solve this next question.